right? And let's say, let me write it in a different color. I'm going to put a little asterisk here because you're going to need to remember this. When we multiply two terms with, that's what this W means, with two terms with exponents that have the same base. That's why I introduced the terms before. So now you know the base is the bottom number here. When we multiply two terms together that have exponents and that they have the same base, then what we do in that case, I'm going to actually change colors to make it a little bit easier to read. We add the exponents. All right, so this is sort of one of the rules that you learn in algebra. It's just one of those things, like when you learn how to add numbers, you learn how to take, and add them together and you get a number. Well, when you're talking about multiplication of numbers that have exponents, you have to learn a few rules. They're not hard, I promise you they are not hard. But let's take it by example. Take a simple one. Let's say you had 2 raised to the power of 3, so 2 cubed, and you're multiplying this by 2 squared. So in a test, or maybe in an equation somewhere, you might have literally 2 raised to the power of something. In this case, it's 3. Here, this is 2 raised to the power of something. In this case, it's 2. Well, what this rule is telling you is, if we're multiplying these things together and they have the same base, which they do in this case, 2 is the same base, then all you do is you add the exponents together. So the answer here is 2, and you take 3 plus 2. So you say 3 plus 2 in the exponent. So that's 2 raised to the power of 5, and that's the answer, 2 raised to the power of 5. You don't have to write this step here. If you can just add these together, that's fine. You can write it down, but I'm just doing it here to show you explicitly what's going on. So that is the rule. We're going to use this rule a lot in this section, but if you have numbers that you're, or exponents that you're multiplying together, they have the same base, then all you do is add the exponents together to get the final answer. And the base is the same, notice that. Now, if the bases are different, we'll do some problems in a second, but let's say this is 5 to the power of 3, multiplied by 2 to the power of 3. You can't simplify it anymore. You can't do anything to it because they're different bases. The rule is that they have to have the same base. Now, you can simply memorize that rule, that's fine, but I would like to tell you why that's the case so that you don't just think algebra is a set of rules that don't seem to make any sense. It makes perfect sense why you're only allowed to do it if the base is the same. And to do that, you have to understand what we talked about before. Right here, what would we do if we were going to write this down? This would be 2 times 2 times 2. That would be this guy, right? That would be 2 raised to the power of 3. 2 times 2 times 2, multiplying it 3 times. Now, if we wrote this guy out separately, like this is 2 squared. So he's 2 times 2. So this term right here is 2 times 2 times 2. This term is simply 2 times 2. And they're both multiplied together, so there's another kind of multiplication symbol in the middle between them because this is multiplied by this. So you see, if the bases are the same, this is exactly the same as 2 raised to the power of 5 because 1, 2, 3, 4, 5. See, the number 2 is multiplied by itself 5 times. So that's why we add them together, because when they're the same base, we end up counting them in the end to make the new exponent, and so we're able to do that. If this were 5 raised to the power of 3, then it would be 5 times 5 times 5 times 2 times 2, and then I wouldn't be able to simplify it anymore. I certainly couldn't add the exponents because they're going to be completely different bases. So it doesn't really help me to do that. I'm not allowed to simplify it because they're different. It would be like comparing a pencil to a baseball bat. I mean, they're just different things. You can't, I mean, yeah, you can count pencils and baseball bats, sure, if you have a bag of them, but it doesn't really make sense to put them in the same bucket and say that they're the same thing. In this case, I'm talking about the base of 2. So I can deal with the exponents like this, no problem, because it's really the same thing in shorthand notation. But if I have 10 raised to the power of 3 here, then this is 10 times 10 times 10, and there's no way I can really write that as a single exponent because the bases are different. So that's why when you multiply numbers with the same base, you can do that. Now let's go on to another guy, just as another quick example. Let's say we had 8 squared times 8 squared. 8 squared times 8 squared. So how would we do that? According to the rule, they have the same base. So all I need to do is write a number 8 and then add the exponents. 2 plus 2 is 4. I just add the exponents. And again, the reason why this works is because this can be written as 8 times 8, and this also can be written as 8 times 8, and they're multiplied together. So in the end, I'm just counting 1, 2, 3, 4. They're all multiplied together, so 8 raised to the 4th power. If this was a different base, it would be a totally different problem, and I wouldn't be able to combine them like that. All right, number 3. Let's say I have 2 cubed multiplied by 5 squared. What do we do there? Well, we look first to see, okay, are the bases the same? The answer is no. The bases are not the same, so there's nothing else I can do. I just write something like fully simplified already. Just to tell you that we've looked at it, this is completely different. This is, if I were to break it out, 2 times 2 times 2. This guy is 5 times 5. So if I wrote this, this would be 2 times 2 times 2 for this guy, and this guy would be 5 times 5. Now they are all multiplied together, but I can't simplify it into one exponent because the bases are different. So, you know, I can't just count them all up and add them because they're different. Okay, so that's the sort of the rule that you need to know when multiplying exponents, numbers that have exponents together. If the base is the same, then you can simply add the exponents. It doesn't matter what the base is, but if the base is the same, you can add the exponents. Now,